Hey everybody, KC0VI Tom. We're going to have a little technical video here on how to desolder and resolder in capacitors in a circuit board. It was supposed to be a nice sunny day, that's what I was planning on doing actually out there in number one, the shop. But it's overcast and it's drizzly out there, so I'm here in the porch and got a strange reflection from a light. I had to get some more light in here. What we're going to do, I'll pan down here and show what we're working on. And like I said, this was a power supply Astron. Get around here. Astron RS7A. This is a little power supply. It puts out like 7 amps continuously, 11 on, 5 amps continuously, 7 amps on max. Just a nice little power supply for a mobile. And what this was on the digi-repeater up in Austin. And as you can see, the biggest thing in here is the transformer. Then we got a large cap, little circuit board, the rectifiers, regulators, and the output filter. And what has happened, we had some noise getting in on the digi-repeater data stream. 60 cycle buzz, and just getting worse and worse, and all of a sudden it no longer was a digi-repeater, it was a noise generator. And brought this back home, discharged the caps. There's 4 caps in this, 4 electrolytics. And they were all out of tolerances, so they're bad. So I went to Astron's website, looked up the model number, the parts list, got a nice little schematic, and throw that up there on the screen. And some of the values in this power supply were not the same as what they had listed for parts and on the schematic. So I contacted Astron's tech support, and they got a response back and says, call the parts man, he'll walk you through what you need to do. So I contacted them, called them, we were talking a little bit. He verified that the serial number and the model number was correct and what parts I needed, and he went off to the tech, came back and says, yeah, there's been a few changes since that was built. So they sent me a bag, and it was, I think, total shipping and part cost was under $20, real inexpensive. Now you can see this big cap, this is an 18 microfarad, and this one here, nope, that's 13, and this is an 18, that's the other way around. A little different in the size, but that's okay. When you have a change, they probably changed for one reason or another. The big thing you got to be careful of the electrolytics is the voltage rating. Now, what a capacitor is, this is just a device, passive device. It is, kick the parts out. There it is. If we cut one of these open, what it is nothing but a long 2 pieces of tin foil or tin aluminum or foil aluminum, 2 strips, and they're insulated with either paper or cardstock. Then it's rolled up to fit in the can here. Now it's polarized, which means that you got to make sure the negative pin here is connected to the negatives of the power supply or the circuit, and the positive, the unmarked one's the positive, that's got to be connected to the positive one. And these are rolled up like this. There's a little bit of dielectric that's shot in there, either a paste or like a liquid and oil. Then they're sealed up, and a lot of them have, the top is not really connected tight. In case something goes on, these will blow off and not destroy the system. These are a little bit smaller ones. And as you can see on this one, it is 18,000 microfarads at 25 volts. That means that this will work on a DC line that's less than 25 volts. I was always told that on this voltage, I always put them on a line that's 10% less than this, so you wouldn't want to put it on any line bigger than, say, 23 volts, because that will have the chance of damaging the capacitor. And I'm not an engineer, I'm just a tech. Now, what a capacitor does, it tries to keep that voltage on that line it's connected to stable. If the voltage starts going up, the capacitor starts absorbing some of that energy and keep the line steady. When the line starts dropping down, it'll start discharging. What happened on the ripple coming out was getting so large because these caps weren't able to absorb and discharge at fast enough and enough energy to keep the DC line steady. So I was going to fire this up, put the voltmeter on it, and show you guys what the DC volts was at the ripple. Well, now one of these guys in there has actually really gone bad, and it blew the fuse. So I got to get a new fuse in it. But first, what we'll do, we'll pop this out. I got the solder station over here. We got meter, got the handy helper here, the parts bin, and we'll start desoldering the parts off the board. And then we'll put the new ones in, and hopefully we haven't let the magic smoke out. of any components that are in there and test fire it up. We got our discharge resistor. Like I said, you want to get like a 10 to 100 ohm resistor to discharge these caps. We got my Radio Shack desolder unit. And what we'll do carefully, one thing you always want to make sure before you start anything is make sure the darn thing's unplugged for obvious reasons. It's amazing how many times I've done it, I've seen other people do it. You test down something and you plug it in, do some test measurements, unplug it, get back in and do some work and realize one time you forgot to unplug it. So you always want to make sure that I just get in the habit of unplugging it and make sure I can see it so I know it is unplugged. When the guy from Astron in the parts department was talking to me about what parts would work in this, what would not, he made the comment that that's a really old unit. I go, yeah. He goes, that's older than me. And I don't remember where I got this. The serial number's in the 6,000 range. We'll set that up like so we can see it. Where'd it happen to my resistor? Here it is. Needle nose. And we'll go through. And since I had this plugged in the other day, I want to make sure I discharge this great big one. Then the other guys are over here. Make sure that's done. This guy over here, he's done. And where's that fourth one? That fourth one's over here. It is there. Okay. So I should not get zapped too bad. And we'll lay the big cap in there for now as since it's holding it up real nice, and we'll grab one of these capacitors. I think what we'll do, can we see? You really can't see that one. There's a capacitor here in the output, and that one I think we're just going to cut the leads and wrap the new leads around it. So and as you can, don't know if you can see it on the camera, but that bottom is starting to bulge out. So that one's not going to be. Now this is a 16 volt, 2,200 microfarad. We'll see what they sent us. 16 volts, 2002 microfarad. So that one was easily replaced. We'll just offside so we don't reuse it. And when I'll do this one again, make sure the polarity is correct. Here we got the negative lead and the positive. So I'll take and I'll wrap those around and we'll solder it back in. Okay, we got it in there. Had to use both hands and little adjectives and a preposition, and probably even a hanging participle phrase. And again, wipe the tip, make sure it's good and clean. Again, I always like to put a little dab of solder. We kind of knock off the excess, and what we're going to do is put a dab of solder between the solder iron and the connection point. That'll transfer the heat. Then we just bathe the connection with solder, and what that'll do, it will soak through, cover all the wires to protect them, plus it'll also give them a nice protective from oxidation. That one's look good, this one doesn't look good. We'll redo him. There we go. Touch him up a little bit more. This is kind of an odd angle, that's what there we go. Okay, the next one we're going to go for is this guy right here. And get it kind of in there. I wonder if we can bring this down a little bit so you can see a little better. And hopefully I keep my big hands out of the way. So we're going to desolder these 2 points here for this capacitor. And again, when you're using a solder sucker, you got to add a little solder to the tip. Clean it. Make sure you cock the solder tool. Oops. Then the trick is you want to get this in a fast process. I like to have 3 hands. Oops. That's why there are some solder stations that have a vacuum pump built in. I wasn't feeling like digging this one out because I wanted to show you guys what it's like the old school way. can see the wire moving on one side, the one lead. We'll just tack a little solder on this side. Transfer some heat. We have to get a little solder on it. There we go. And we'll set this down. We'll suck out that. And as you can see, excuse me. As you can see, the hole's open. Okay, was not. Oh, there it is. There's the negative lead that was on that side. So I would assume we'll take a peek at this a little bit better. We'll get the other one ready to solder in. And this was a 470 at 40 volts, and the one they sent me was 470 at 50 volts. Again, the voltage is higher than what I'm replacing, taking out, so that'll be fine. Okay, the red lead then runs to this deal. Here's the positive side, and so this leg here is the negative. We got one connector here, negative, just verifying it. So we're going to slide this up from the bottom like so. Just had to follow the schematic, make sure it was right. I wish I had a pictorial on how this is laid out. Again, a little dab of solder. We'll set it there to transfer the heat. Flowed real good. So the solder, transfer the heat. Don't take our side cuts. Now carefully when you trim these wires, because these things, little tips can fly off into, you don't want to get hit in the eye or hit somebody or have it fall on another circuit board if you've got multiple things in your bench working. Going after our next one, which is this little guy here, 100 microfarads at 25 volts. And that goes here and here, and the negative side is that way, so I don't have to chase myself around. Again, have that cocked ready to go. I wipe the tips, we get a little flood on it. Add some solder here to transfer the heat. Now when using one of these solder suckers, you want to be careful is tip, put it here. I'm going to spin this when you recock it. Now if you watch, of course it'll do it. Sometimes you get some of the solder that you sucked up will fall out, so you don't want to do it over your circuit board. And we'll wiggle this guy. Well, he's got most of it out. We'll get the other side done. This is on these capacitors. Sometimes you need to go back in and add a little bit of heat to the circuit board to break up the last of the solder. I've never had that much luck working with solder wick. That's a braided material that you can use to help suck up. Okay, that side's loose. We'll just add a little bit of heat to him. Now, thing to remember when you're desoldering or soldering, the solder pencil or solder gun is just transferring heat. It's not a pry bar. It's not a hammer. You just apply heat to it. I gotta add a little solder to transfer that heat. Then you can wiggle the wire and hopefully you can get this pulled out. Now in this instant, we got a little blob of bent, or not a blob of, the wire's a little bent, so we're just going to trim this up, get the bent out part, so now it should slide okay through the holes. Again, make sure you don't drop any of the cuts off in there. So again, it's starting to bow up a little bit on the bottom, so there it is. Negative lead there. Negative towards the camera. What I like to do is spread them. There's a little bit. Oops, that'd be interesting. A little bit of solder to transfer the heat. Block that up. Okay, then we'll go in and trim it. Now, like on this one, since we got It's a little bit bigger. We got a little, you got this pad where we solder down. This is an output pad. You want to make sure there's nothing jumping across that space between it. Little screwdriver just run it up and down, make sure there's nothing there. And same over here. That looks good. Now the last one is going to be this big guy, and we're going to have to do something a little different for that. Now on this big cap, this is a 13,025 volts, and if you can see right here, there's a plus. That is the positive of the capacitor. You should never put your finger across both of these. Even though we discharge this, it still could have a little charge in there. So now we're going to take our replacement cap, which again different. Negatives here. So we're going to mount this like so, and I got to do a little modification to stuff. And there may be, there we go. I'd like to be some more yelling and screaming, and then this over. This board, or this power supply, is so old. When the parts man was telling me about this cap here, he says, now you're going to have to take a razor blade or an X-Acto knife and trim off that green masking material, and so you can solder onto it. And it says, dude, this thing is so old, there is no masking material on it. This is a very early one. We'll see if we can't, or if we can use that. No. But we got, again, negative to this side, which goes over to that negative. And this could be interesting. It does not want to behave. Okay, spread these. There we go. Yeah. It's just got to hold it temporary. Wipe the tip, add a little solder, transfer the heat. Now if you go in here, bathe the connection, By George, I think we got it. Okay, I had to take out the old clip, replace it with this new clip, and I just realized I had taken my mic off, so, oops, sorry about that. We'll set that down, and we'll just kind of rotate this. What I'm trying to do is look down this way, make sure we're not going to hit the side, we're not hitting anything. That way we're done here. I'll take and right at my needle nose. There's my needle nose. We'll hold the inside nut, get out here on the screw, and just tighten it up just a tad bit. Then we'll tighten this screw on the clamp. Wow, that's magnetic for some reason. Doesn't have to be tight, just snug so the board doesn't move around. And we are perfect. Okay, now comes the moment of truth. Okay, we got power supply board secured down. We got the voltmeter. It's set on volts DC with AC ripple. We got the power cord here. We're going to plug this in. The power supply switch is off, I hope. And here goes. It's either going to work or it's not. And we got 13.6 volts at very little ripple. Hey, we got something fixed. I have a demonstration that actually worked for once. This is fantastic. This is great. I'm going to shut it off before it catches fire. No. One thing I'm going to do, I will take, I got some cardboard from, we'll just say an adult beverage container box. And I'll cut out the cardboard to cover up the board, so in case something would happen to fall in the power supply, it's not going to fall down. One of these ends, I'm going to do this, I'm going to hit that board, and I'm going to get knocked on silly. So, as we shut it off, power drops off. Good. The ripple goes up a little bit, which is good. Okay. Go back to here. We get a jump up 13.6 volts. There was a variable resistor in there. We could set that up to 13.8, but I think we'll just leave it as is because it seems to be working fine. Because normally when I try to adjust something, then, oh, that's not too bad. No, I'm not going to do it. Usually I try to get my fingers in there and start breakdancing, and people wonder what I'm doing. On that, be sure to tell your friends, neighbors, other hams. Subscribe, hit that bell to get notification when new videos come out. Add comments below. 7-3, everybody.